Hi, this is Shiksha and Nikit, and we have prepared a little video which is a demo for platform device driver and Sysfs interface for SCSR04 as a part of our assignment 2 part 2. So here HCSR04 sensors will be registered as platform devices and MISC devices. Now when the platform driver module is loaded and probe function is called, then HCSR04 platform devices will be initialized. For our convenience, we have already installed the device module and driver module. Now I will show you the directory locations where platform driver and MISC where platform driver has created platform devices and MISC our sensors has been registered as MISC devices. So you can see this sys/devices/platform directory. Here our devices have been registered as SCSR04_sensor1 and sensor2. Under the MISC directory sys/class/MISC, you can see SCSR041 and SCSR042. So these are nothing but our sensor devices, which are also our miscellaneous devices. Now we are going to see the Sysfs interface path for our devices which we have created. Here in this directory sys/class/SCSR, you can see those two miscellaneous devices which are nothing but our sensors. So now in this directory we have created attributes for our sensors, and these attributes can be used for Sysfs functionalities by the user. Here's the list. You can see distance, echo, pin, enable, frequency, mode, trigger. These are the attributes which we have created, and subsystem, power and U event are by default. Similarly, you can see for sensor device too similar attributes. Now I'm going to show you the functioning of Sysfs interface, how we can access that is how we can trigger our sensors via Sysfs interface. This is the directory where where all my modules and my scripts are. Now I'm going to run the first file, sensor1 multishot.sh. This is nothing but a script file for triggering my sensor1 for multishot mode. So you will see continuous trigger and continuous pulse width being calculated and captured by the sensors. So as we move the object away and from the sensors, you can see the various pulse widths being captured and calculated. Now since I have provided a sleep time of 15 seconds, so it has stopped. I have also requested my distance attribute to show the latest distance, which you can hear in the last, that is 217. Now these measurements are in micro, these are nothing but microseconds. These are the pulse widths. Now I am going to show you the functioning of one shot mode. I am going to run the file sensor1 one shot. This is nothing but it will trigger the sensor 1 only once. Now you can see that it has entered into my program, and it has printed one shot mode will trigger, sending trigger for one shot mode. Here 141 is the pulse width which was captured after triggering the sensor once. So this is the way which we can access our sensor devices via Sysfs interface. Now I'm going to show you the user dev interface. For that I have this tester executable file. I'm going to run it. Now it is asking me for the GPIO pins to be set up. So I am going to set up GPIO pins. For sensor 1, my trigger pin will be 5. My trigger direction pin will be 24 and mux will be 44. Then for the echo pin will be 10. These are the pins, nothing but which we chose. You can choose any pin which you like. Now the user interface is asking me for the pin configuration of sensor device too. You can see that the trigger pin is 6 and the direction pin is 36. There is no mux pin, so I am going to put -1. Then the echo pin is 1. And if you can give me 2 minutes so I can get other 2 pins. I apologize for this delay. Anyway, we can continue with that. It doesn't matter. Now it has entered into one shot mode. It will ask me for if I want to perform one shot or multi-shot for sensor 1. So if I choose 0, 0 is the mode for choosing for sensor 1 mode 0, and I'll give the sampling frequency. In this mode, sampling frequency is not really required. Now it is asking me for, you can see the 4 options available. If you press 1, then it will trigger to get the distance, and 2 to clear the buffer and get the distance, 3 to just read the distance which is in my FIFO buffer, and 4 to exit this mode. So I'm going to trigger it. Now here you can see the calculated object distance is 3 centimeter. And this is the status of my previous buffer which I ran, which got filled when I ran the program previously. Now if I run trigger again, then it is going to update the distance, and you can see it is 6 centimeter. Then again here you can certain errors are acceptable for sensor measurement. Now if I want to exit, I'll enter 4. Now if I want to continue with the sensor 1, then I'll press 5, or else to choose sensor 2, 0. So I'm going to choose sensor 1 only. Now if I want to run my sensor 1 in multi-shot mode, I will provide mode as 1, and sampling frequency as 30, which we can choose any sampling frequency, but the condition being sampling frequency should be less than 40 kilohertz. We cannot choose large frequencies. Now if I want to trigger it, I can press 1. Now you can see the continuous capturing of pulse width for multishot. So our problem statement has been successfully realized, and if I want to exit or break this continuous capture of pulse width, so I'll press 3 and then enter, and then you can see that periodic sampling mode has been stopped. So that is it. Thank you very much.